I'm Razvan. It's good to be here. I think I've been presenting for Xen Summit for a while now. I mean, I've only been in person last year in Lisbon. So now it's the second time. And I actually should have been here together with Andre and Maria. So this is kind of a compound presentation with all of us. That was the plan. We actually talked to Stefan about this. We're going to join this. We made our initial steps. However, they are doing an internship now in London. The internship ended, I think, last week, or was supposed to end at something like 10th of September. And Maria didn't have a visa because, yeah, United States, Romania, that's a bit complicated. And it was a bit of a hassle. So we're going to try as much as possible to be part of this next year. We'll see where it happens. If it's going to happen in the United States, we're going to get the visa very early on to make sure. I have one, Andre has one, Maria didn't have one, so that was a bit of a trouble. If it's going to be anywhere in Europe, we're going to be there because you're going to see there are items that they are working on, which I'm going to present, which are kind of half-baked at this point. So we're going to aim to have it ready by the meeting next year. All right, so for those of you who don't know, you have to plug this in order to make it work. That's very important. And also, you have to plug it in something where the USB port hasn't been screwed up by something in the laptop. So I think that should be working okay. Let me just try this out. Yeah, it worked. So for those of you that do not know, Unikraft is a unikernel. Well, it's not actually a unikernel. We call it a Unikernel SDK. So the ecosystem to actually create unikernels, right? So we can see here it says fast open source Unikernel Development Kit. It gets you the bits and pieces to be able to create unikernels. Unikernels are very small applications that are shipped together with your operating system. So you have everything in one box, and then you're going to be able to deploy that. So Unikraft comes along with the building blocks. The logo itself is kind of a set of components. So all of the building blocks that you typically find in an operating system, in the core libraries, networking, standard libc libraries, whatever that may be, and then the application. All of those pieces are tied together, carefully selected to create the unikernel. And what we, let's say, use as some sort of a bit marketing term for Unikraft is extreme specialization, being able via its build system to create your highly optimized unikernel build for your use case. That use case may be efficiency, it may be performance, it may be security, it may be whatever, a resource consumption for embedded, whatever it may be. Unikraft has been open for about, I would say, 8 years. It started as a Xen project. So our connection between Unikraft and Xen is because it started as a Xen project. The initial, it was a research project, and how it came to be was as some sort of minimized virtual machine based on Xen. They threw away Xen, store a lot of other stuff to make it as efficient as possible. So that's how it started. KVM support came out later on. And it's a pretty healthy project. You can see here the evolution of the GitHub stars. We are now close to 3.3K stars. I think there's 1.8, close to 1.9K people on our Discord servers. We are part of Google Summer of Code for 4 or 5 years. I need to think a bit, but we are now completing our final part. So we are heavily active, and we are also in connection with the Xen community. As use cases for Unikraft, there are 3 prime ones, and we're going to look at them because what Maria and Andrea are doing, and what we are also focused on with respect to Xen, are going to be related to this. The prime one, actually the one in the center, it's cloud. There's also a startup, Unikraft.io, Unikraft Cloud, which creates highly effective, highly efficient virtual machines based on unikernels to run on the cloud. Another one is embedded, meaning you're going to target low-end devices or small devices because you want to be as efficient as possible. Here you can run it as, because you know of Xen ARM, you can run it actually as a virtual machine, but you can also use the bare metal use case. So there is a particular set of projects where you're going to run unikernels as very small applications tied together with the operating system as bare metal application. One of the core items now is making this work on Raspberry Pi. It kind of works for some items. We are looking ahead for the other ones. And some which you're going to see now with stub domains is for isolation. Imagine you're going to look into running something small. You don't want that to have a large attack surface. You want to have it, is isolated. You can run Unikraft there. So any sort of drivers you're going to use, any sort of component that you want to run highly isolated, look into this. There is a student who I'm working with who's looking into tying if you know OptiOS for the embedded and the trusted firmware part together with Unikraft and have an interface for the Unikraft as a driver interface and keeping the secure part in Opti. This is kind of the overall image. Now, what's been happening during the past year since, because this is kind of state of Unikraft with support in Xen, what has been happening the past year since Lisbon? I mean, 1 year and 3 months, I think, with Unikraft and tied with Xen. The prime item is something we call catalog core. Just to give you a bit of an insight here, let me see if this is available. It's available. This is we call this catalog core repo. Now, the main repo of applications is actually called catalog. So if you're going to go here and go into catalog, you're going to see a bunch of application runtimes that you have available in the open source project running Unikraft on different platforms, Xen included. Because the aim is to get those applications running, right? You want to be able to run any sort of applications. How this catalog works, there's a companion tool in Unikraft that's called CraftKit. So what CraftKit is supposed to do is to make it very easy for you to build, to configure, build, run, package, deploy, and orchestrate Unikernel-based VMs. And CraftKit does that for you. And the catalog that you saw here, this is reliant on using CraftKit. So for example, if you're going to go in a given application, let me go into, maybe I'll go into a native one, and I'm going to go into HTTPC. You're going to see here that we have something that's called a craft file. A craft file is a spec written in YAML that gives you what's required to be able to build this application. And then craft file translates this into the basic tools that Unikraft uses to build and run applications. If you're going to go for something more complex, so for example, we go here and going to the craft file, this is going to be larger. So it has a bunch of configurations that's already predefined, and when you run something, it just does stuff behind the scenes. The good news about this, it makes it very, very easy. The bad news about this is it makes it difficult for devs, for maintainers, for testers, for people to debugging. Because if it's usable, then it should be very easy to use for the main case. But if you want to debug, if you want to do some updates, it's not that easy. So what we've been doing is we created this catalog core repo, which is targeted towards developers and maintainers and testers and all sorts of technical people that want to tie with Unikraft. And what you see here, you have a particular directory for each application. So for example, if we went, let's go into Nginx because maybe this is more interesting as a complex application. What you have here are the necessary bits for running Nginx. And so for example, there's something, there's a kernel-like interface that gives you what you're going to require to build this. And then what we have on top of that, we have, let's talk about Xen because we are here at Xen. We have a basic configuration file that we're going to use, as you know, for Excel Create to be able to run this. So this is pre-provided, we provide this, but when you do that, you're going to only use the basic set of tools to make this happen. You're not going to use CraftKit or something, you're going to just use build and you're going to just use run. And now comes the thing that I'm ashamed of and the bad news. For some unfortunate incident, let me just show you how this is working. If I'm going to do this on our server, I get this weird issue. And this is actually because I have, we have a server running Xen, which everyone goes into. And that means that things break because someone did something of a custom build or something. So I was trying also to do the default Excel install, and yeah, that is another issue with Xen utils 4.20, something like that. So I'm not sure what the problem is here, and it's going to be very interesting because I can show you Xen running on ARM64. Yeah. Yeah, I guess so. The weird thing is that I'm not sure what they did because the kernel itself, it seems to be a very non-Xen kernel. I'm not sure what happened there. I looked in the bootloader and said through it. Matej mentioned he's going to look into it. This happened during the past weeks, and basically I was so hammered with the other stuff I didn't have the time to check it out. However, the nice thing is we have things working on an ARM64 board. So finally, we cannot run at this point. I cannot demo you the way this works on x86, but you can do it on ARM. That's the interesting part. Because you have a board from NXP, which we installed Xenon, and that's working. And we are still struggling to get it running on a Raspberry Pi 5. We're making progress towards that. So just to give you a hint here, so here I have a catalog core repo. And let's go into the Nginx directory. And just to make things simple here, we have, let me just run this. We have a script here that, so build, let's build it, for starter, let's just build it for KVM to see it come fully. So what it does here, it's running behind the scenes, it's running make and the configuration files to get everything. This is Muscle, a C library. And behind the scenes, it does all the stuff required to build a unikernel image. I'm going to just leave it running this way. I'm also going to show you how this is going to work on Xen. But just to see that working, let's connect to that ARM64 board that I showed you earlier, just to see that indeed things are working. So it was IMX. Just a sec. No, IMX. Okay, so this is a board. I think it's running a 4 something kernel. Yeah, 4.14, but it's with Xen install. So if I do Excel list or something, I can see this running, right? And I have here I have a configuration. So if I go, for example, in CLO, okay. This is the actual image. So this is a full image. It's a simple hello program. There are the others here, Nginx, CPP, hello, some other stuff. This is the basic image of a unikernel build running on Xen, right? And then we have the config for it. And now I'm going to go Excel create. Okay. This is very simple. It's nothing out of the ordinary. It's just running a VM. This is going to be similarly, for example, if I'm going to go into C, HTTP, or the others, except there I need to create the network and a lot of stuff like that. And this is precisely what's happening here as well. What you see here, this is a build of Nginx running on top of Unikraft. So for example, if I do this, and now if I look into workdir build Nginx QEMU, right? This is the 1.8 megabytes image that can be run as a virtual machine. So let me just show you how this runs as a virtual machine. Scripts run QEMU x86. This is running with KVM, right? So this is a web server. This is Nginx. And if I would go here and I would say curl, I think 124. I'm not sure if I'm doing this properly. Yeah, I'm doing it properly. I just curl this instance. So for example, if I'm going to close it, yeah, nothing happens because I close it. So it's an actual virtual machine image that, once again, it's 2 megabytes in size, and you are able to run an Nginx application on top of that. This, of course, would have been similarly done if I'm going to do it for Xen. So I'm going to do a Xen. Let's do an ARM64 build. Why not? Because the x86 already doesn't work. So this is not going to do it exactly like that. It's going to have it built for ARM, and then you're going to end up with this very, very small, tiny image that's running as a virtual machine, right? It's only your application running there. Okay. So this is generally how things are working with the catalog core and with Unikraft, and those been happening lately. And we've added applications. There's KVM and Xen support for all of them. It's developer centric and it's running native applications. However, the problem that we've been facing for the past 3-4 years is that no one cares about that as a user. I mean, for us, for devs, it's I'm going to tick around. I'm going to pull that option. Let's save another one kilobyte from this. People don't usually care. They just want things to run. And how do they want things to run? I have this Docker file where I'm able to build the application. I want to run that application with your kernel. Let's run it. I don't want to spend time creating configuration files, patching muscle and whatever libraries and making it see it's working with that particular version. I have this version. I have an ELF file from that. Let's just run it. So because of that, we added support for what we call binary compatibility, which makes it very easy to run. However, the downside is it's not that fast because it has to go through what we call a shim layer that exposes a Linux compatibility POSIX-like syscall interface. And you're going to make syscalls to that, and you're going to run it. So with this in mind, we are actually able to run binary ELF files on top of Unikraft. You have your ELF file, and then that ELF file is going to be loaded. It's going to make system calls, and those system calls are going to be directed to the actual underlying Unikraft implementation. This has been working quite okay for the past 3 years on KVM x86. What we've been doing during the past 1 to 2 years is making it work on ARM KVM and on Xen x86, and hopefully we're going to make it work on Xen ARM as well, right? So getting the there's an application we call the ELF loader, which is a native application. This is going to load the ELF Linux application, load it in memory, pass control to it, and then make it run on our kernel, as you do on a Linux kernel. Okay, so this gets us to the first item with Unikraft and Xen, which is the part with Xen binary compatibility and how this happened. Okay, what do you require to have binary compatibility? Maybe let me just do a very quick demo of this, just to show you how it works. So if we're going to go here in ELF loader net, let's call it, right? And I'm going to do setup sh, and I'm going to then say crypts build QEMU x86. This is going to build the ELF loader application. So this is, as you can, it's called ELF loader. This is an application that was kind of more of an application bootloader. Its goal is to load the application and then make it run. It's compiling really fast, right? And then what it does here, it loaded a binary application. So what it did here, for example, it has this application that's part of the root file system of the application root file system, which is a C server, right? So it's this one. This is going to get built as an ELF file. This ELF file is going to load it. Just to show you, I'm not joking. I'm running the proper stuff. Let me just show you this. Let's switch the port. Let's make it 8888. Okay. Let's build it. Okay. I'm building it static pi because you can also use dynamic pi, but static pi is you have to have the executable, no dependencies. If you're going to dynamic pi, you also require the libraries and have to pull them out, so it's just easier for test purposes. But dynamic pi's work as well. Okay, so then let's run it again. You're going to not build anything. You're just going to run the same ELF loader, but now with a different binary. And now it's listening on 8888, right? Loading it and putting it over there. So for this to to add to our, let's say, ecosystem, we wanted to have Xen binary compatibility for this. Okay. Now, how does this work? Currently, Unikraft is using PV-Xen, right? x86 and then ARM. The way the LFloater works and binary compatibility, imagine you're going to do a syscall, and then you have to trap that syscall and redirect the flow to the internal implementation in Unikraft, to the, let's say, the implementation of a socket or the implementation of a creation of a thread. You have to direct that. So for binary compatibility for Xen, what we had to do is to add support for PVH, because that's very, very similar to the current KVM code, and it made things very simple. Okay, so that was what we got. We were able to get Unikraft as a PVH build. Unfortunately, this is not yet upstream. So this is Unikraft as a Xen PVH build, and then this is now available here. It's not part of the Unikraft core repo, because it's kind of something we need to properly integrate with the existing platform work and with the existing Xen platform. But this is available here, and you can try it out and see how it works. You're going to be able to run binary applications with binary ELF Linux applications with Unikraft on top of Xen. Okay. So what changed is a bunch of items were memory management for initial support for PV were imported for KVM, and then drivers, grant tables, networking, they were added over there in order to make this happen. This is something very hard-coded at this point, particularly with respect to the page table. So this needs to have some rewrite. And I told you earlier about use of CraftKit to make things easier. This is not yet available. So CraftKit does support the Xen part. We can do this. We're going to add this in the catalog core, but still support for the CraftKit tool is not yet there. Andre had initially worked for CraftKit Xen. So the initial part, Xen PV, Andre did the work. Then he did the work on PVH, but this is yet to make its way in CraftKit. This is one of the items. The other part we've been working on, and this is something we actually got from Xen Summit last year. So those of you who were there maybe recall we had a discussion what would be some interesting projects, and there was an old idea, I think, Andrew Cooper, if I recall. I'm not sure how that happened. Yeah, I'm not sure if that was discussion. I don't recall the. Marek. Yeah. I know there was. Okay, we have for some time been looking at running QEMU in a stub-domain. We have an old Linux build. Would it be possible to run this on Unikraft, because that would make it even lighter? And that was kind of the idea. So there are two topics here. I mean, the main topic is using QEMU as a stub-domain, but you want to run it on Unikraft. So that implies you want to port QEMU on Unikraft, which is kind of very weird, because you use QEMU to run Unikraft, and then wait, what does that mean? So it's actually running the Unikraft application with on top of Unikraft to be using the features that it has available over there, mainly the I/O part in given applications, right? So how this is working? Typically, you have the DOM0, so you have the controlling domain, you have the hypervisor, and then what you want to do is any sort of I/O related emulation calls that your virtual machine, your DOMU virtual machine is going to use, it's going to pass to the stub domain that's going to be provided by QEMU. And we want to have this tied together in a isolated, small, tightly packed unikernel environment, right? You get another one, you do another stub domain, everything passes through there, and then you're going to have this in QEMU. So this was the idea. This is the idea, running QEMU on Unikraft. And Maria worked on this for about 5-6 months, and it's kind of half done. We expected it to be done, but it was very messy. You're going to see why. There were two options. One option was to have this done as a bin compat application. So get the QEMU binary and run it, and that's going to be it. But then I said, if this is going to be highly efficient, highly effective, very small, we need to port it natively. We need to run QEMU as a native port on Xen. I'm not sure if this is recorded. I'm guessing it is. So that's it. QEMU architecture sucks whatever you want. It's astonishingly bad. You have pieces of stuff everywhere. It's messy. It's very, very messy. So Maria struggled quite a lot with that. You're going to get me to, but if you're going to just pull some item, I want just this part. No, you have to go to edit headers. Within in each header, split them up. It's not cool. So what happened here? So yeah, this is kind of the items that we know of, blah, blah, blah. What was she able to do? In order to run QEMU as a native app, you're going to rely on the dependencies of QEMU. When you build QEMU, so imagine you're going to do /configure and then make QEMU. You're going to require glib, PCRE2, the actual Xen tools part, an update to the libgcc that we are using. So she spent a lot of time actually not doing something with QEMU. So this was kind of the, I wouldn't say fun part, but more manageable part. But then you have to actually do QEMU. So you do the dependencies, but then once you go into QEMU, well, that's all the hell breaks loose. And unfortunately, this is we're going to see how this is going to be something maintainable, because I think she picked a 8 or 9 version of Xen. But then the updates that she did for this, there are some scripts that pull the required bits from there only to have a minimal QEMU build. This worked for that particular version. If the architecture would have been better, you'd have some sort of config options and say, leave this out, leave this out, leave this out, only do this for this, and that would have worked better. But you don't have that. So there's a bit of hard-coded work in that part. The main issue we stumbled into is clone, unfortunately. QEMU makes use of threads and some other items there. It does clone syscalls. And the clone syscall within Unikraft, it's not the clone syscall, let's say the clone call. You have to have some sort of mapping of the QEMU call. Is not working properly in current Xen. So this is our this was our bottleneck. We started in June, then she went for the internship, and when she gets back in about 1 week's time, this is going to be the resume. Getting the clone part working for Xen, that's generic for Xen, and then that would be able to unlock the current running of QEMU. So at this point, you have a build, but then once you start running QEMU, it's going to crash because there's some, I don't recall, some stack or registry item that that you bump into when you do the first clone within QEMU. Okay, so this is kind of roughly it. You saw the catalog update, so continuous support for Xen and making sure all the applications are working. With native and bin compat, you saw the work that Andrei did. We have bin compat working for a bunch of applications. Still, this is a bit hard coded at this point, so going to improve it. The aim is to have this upstream in the main Unikraft repo. There's going to be continued work from QEMU stub-domain. Maria is going to be a master student, so my hope is that in a year's time, so by the next Xen Summit, this is going to be more or less complete. Not necessarily usable for some sort of production use, but still in a good shape that you can take it for a run and start doing it and providing feedback. And yeah, we are in good connection with the Unikraft community. There's another project that we work on, so probably next year we're going to work on that, which is adding, improving the Argo support within Unikraft. Matei is working on that. So potentially next year we're going to have, let's say, these 3 talks, one on Xen bin compat, the other one on QEMU stub-domain, and the other one on the added Argo, improved Argo support with Xen. That would be from my side. These are some references for those of you who are interested in this. So it's an ongoing environment. I'm just going to show this and then I'm going to end because I know my time is up. This is the, is it? Yeah, it should be over here somewhere. Just show this. There is a chat that we have on the, you can see it's called Xen UPB. And here we have, it's in Romanian. So unless you know Romanian, you're going to see it. This is our group of people who work on these items. We talk about the stuff, how do we discuss it. Here we have Andrei, George as a newcomer, Maria, Mate, and the others. So we are pursuing this. And but apart from that, there's also the, let's say, community-centric, within Discord, we have the PlatZen channel where we talk any sort of particular items. Yeah, that would be. Thank you so much. If there is any sort of interest in joining us, please do it. We are a welcoming community, and we appreciate any sort of support you want to put up. Thanks.
You want to take a question?
Yeah, yeah, of course. If there are any questions, I would be more than welcome.
5 minutes.
Yeah. Sure.
Can I ask Jürgen's question he put in the chat?
Yeah, also, I did not see
So
we'll do one question from the chat first. Sorry, I think it was here before.
you decide. You guys decide. I'm okay.
I'll go ahead, sir. As I understand, it's your kernel for Xen is based on MiniOS. For PVH support, you could have taken it from MiniOS again, as PVH is supported in MiniOS since several years.
The Unikernel itself indeed is based on MiniOS. That's how it started, but that was in 2017. So that was 8 years ago. It's been to a tremendous amount of, so that was an initial discussion as well. They looked into the MiniOS part, but it was just easier to copy the plat KVM directory and make some updates to it. Yeah, so it makes sense, but the kernel itself evolved so much that it was simply easier to go cp/plat/kvm in /plat/unikraft minus being compat, and that was it. But yeah, that's totally true. Yeah. Yeah.
Do you have a catalog for Golang?
What do you mean by that? I mean, we are able to run Go applications. So if you're going to go in the catalog, for example, here.
Yeah.
No, not in, for catalog core, no, not yet. So this is still work in progress to update it. There is Python. There are some pull requests for Lua. We are working towards that, but the normal catalog, you're going to go here. And if you go into library, there's Go, I think 1.20 something. Let me see. HTTP Go. No. No. It's not here because this is not the library are language runtimes that are not are interpreted, not compiled in. But here you have HTTP Go, HTTP Server Go, for example. This is available over here, right? But note that this, however, is being compat mode. So there is the native part, which is over here. So if you go into Unikraft and then you go into libgo, this is the native part where we have the libgo library running on top of Unikraft. This is something that was left off. So I think it's about 2 or 3 years. Yeah, 2 years. So I'm pretty sure it doesn't work. So meaning the native mode. We are going to work on this. So if you want to join, please join us. There's a bit of work here because you depend on GCC updates, but we have it on our radar.
Okay, thank you.